Hello, welcome. How are you all doing? Are you enjoying the conference so far? Okay, good. Well, welcome. Today, we're going to be talking about Model View Controller for iPhone OS, or iOS as it's now called, right? An essential design pattern for making flexible software. And I'm Ken Kushenda, and I work on iPhone software. Well, today, as you might be able to tell from the name of the presentation, this talk is going to be about design patterns. Well, what are design patterns? Well, there's a number of them up there on the slide. These are good solutions for common problems in software development. You're probably familiar with them. Well, I'm going to pick out one of them today, Model View Controller, and that's going to be the main subject of the talk. So why should you care, right? Why is this a big deal? Why are you here? Well, I'm going to try to answer that question for you because, well, probably you want to make great apps, right? Yeah. OK, so now, how can this all help? Well, going back to the beginning of iPhone development, right? You had a small screen. We have some great documentation and APIs, and things are a lot simpler than maybe they used to be if you're familiar with desktop application development. And it was really pretty simple to come up with an organization to just manage one screen of content at a time. Well, then along comes the iPad, where the screen is bigger. You can fit more widgetry on the screen, more content presented to your users at one time. Things get a little bit more complex. And then maybe you want to come up with an application that will work on both the iPhone and the iPad at the same time. And it can seem like you're serving two masters at the same time. Well, and that can be a little bit complicated. And so what this talk is about is how Model View Controller can help you sort of tackle that problem and come up with some good solutions. OK, so now, if we sort of look at things formally, if some of you studied computer science in school, you're probably familiar with a drawing like this. Yeah, there'll be a test on Friday, right? So study up, maybe, right? And we're going to be talking about this diagram quite a bit as we go along. But really what I'm going to try to do is tie that diagram and the concepts there back to the real world. Right? Because again, what you want is to make great apps, and you want your software to stay flexible, easy to change, and whatever. So I'm really going to try to tie this back to the real world. And so I was trying to think of, well, how could I present this all to you? So when I think about the real world, I think of maybe a supermarket tabloid, right? You go down there and you see these things all the time, the 10 best celebrity weight loss tips ever, right? You see these kinds of things all the time. I agonized on the copy, so I'll leave it on the screen there for a second, so maybe you can see that there, right? OK, so I figured what I would do is try to talk about Model View Controller and give you the 10 best MVC tips ever, OK? To, again, tie this back to the real world. And again, the goal here is to give you some tips that will help you make your software flexible and keep it easy to change. And again, the goal being for you to develop great apps, as you have been. And of course, we'd like to see more and more great apps as time goes by. OK, so let's jump right in. So the number one tip is to learn Model View Controller for iPhone OS, iOS. It's, old habits are going to die hard, so forgive me for that. So learn Model View Controller for iOS. And this is all about learning the common conventions as they are applied in iOS, and learn about how they're built up from other design patterns, which again are very, very common throughout the OS. And so first of all, I'd like to focus on the connections between the objects. So going back to this diagram, you'll see that, right, we're going to focus just on those connections, how things move around, how the updates and changes circulate around this Model View Controller system, okay? And the conventions that are used in iOS for that. And there are several, but primarily I'm going to call out three of them: target action, notification, and delegation. OK, so what are these? Target action. Now, a lot of these are to promote loose coupling among software elements, to allow you to tap into the functionality made available by the OS classes and the APIs without subclassing. Here is a concrete example. So if you have a button in your application, you don't need to subclass the button to get custom button clicking behavior. You can set a target that implements a method, and basically that target tells the button, hey, when you're tapped, call on me, and I'll go and take care of that custom button clicking behavior action afterwards stuff. Okay? So again, target action. Something that's very common. Another that's common is the notification. This is used in the keyboard. When the keyboard comes up onto the screen, of course, you don't have control over that. That just happens when the system detects that text entry is going to happen. And so the keyboard sends out this notification so that you can do things like perhaps resize some views, or perhaps initialize some objects which might validate some text, things like that. And so notification is, again, kind of this one-to-many type of communication between objects in the system and your code. And primarily, that's NS Notification Center takes care of that. Okay, I'd like to spend a little bit of extra time talking about delegation, because it's going to come up many, many more times in the talk. So let's talk about delegation, another common pattern which is used throughout the system. So when a user taps on the return key in a text field, the text field goes over and asks the delegate, should I end editing? Should I actually, take the insertion point out of the text field and make the keyboard go away? And the delegate in this case says yes. And this way to link your custom object up to a text field in the system is done through a UI text field delegate. Well, many, many classes in UIKit implement a delegate to do work of this kind. Okay? And there's a really good way that you can detect. Even when you're reading code, maybe you've downloaded some sample code and you're trying to understand how it works so that you can sort of implement some of that same functionality in your program. These will, did, and should methods are sure signs that you're looking at some delegation going on. So an example, in the UI application delegate, the application says, well, I'm about to resign. And it will call out to some of your custom code. If you implement it, application will resign active. The next one is a scroll view when it zooms. When you pinch onto a scroll view to zoom, you'll get a callback on your code if you wished. If you implement this method, scroll view did zoom. And another example, you click on a clear button in a text field, you'll get a call out to determine whether or not the text field should actually clear its content. So again, these will, did, and should methods are used really, really quite a bit throughout UIKit and the UIKit classes. And again, the idea for this is to keep your code flexible and easy to change. Keep things from getting all balled up into one big class that does everything, but keep things parceled out among different classes so that you can keep your code flexible and easy to change. This will be a theme I'll be returning to several more times during the talk. So okay, so a little bit of a look at how these classes link up with their updates and changes. So learn MVC for the iPhone OS. Of course, there's a lot of great documentation about those subjects in the iPhone Dev Center online. So if you want to learn more, that's the place to do it. Okay, so number 2. So now use MVC to divide your work up. And so, a lot of times when you have your application, you've got a big idea, and perhaps it's even too big for you to work on by yourself. So you have to sort of divide up the work and figure out how to make manageable pieces that will all communicate together to implement this big idea that you have. Well, how does MVC help you do this? And I like to think of it as that it gives you a set of useful buckets, So going back to this diagram again, we'll focus in on the big boxes, the actual model, view, and controller. So a model, I like to think of model as being not just about data, which is sort of the most traditional way of thinking about what a model is, but also algorithms, and perhaps also networking, things that are beneath the level of the user interface. I like to think of all of that as the model. View is all about display, event capture, not event processing, but event capture. I'll return to that again later. And also visual appeal, making your application beautiful so that people love to look at it, love to use it, and they'll tell their friends and they'll go download it as well. So that's what the view is really primarily focused on doing. And then the controller is, again, all about coordination, things like delegation and odd jobs. So let's look at a bit of an example, a sort of a concrete example of how these things might actually fit into a real program. Let's just say that I want to make a code-breaking machine, take some ciphers in and try to figure out what the plain text says. So you might imagine that my model would have features and functionality for dealing with ciphertext, with plain text, and cryptography. And a lot of times, the custom work of your application, the real app-specific stuff that's going to differentiate your app from other applications, is focused in on the model. That's where a lot of your custom wonderfulness is going to get added, right? Now, when you go to the view, you might imagine that such an application might show you a bunch of ciphertexts in a view, might give you progress, indications, things like that, add and delete buttons, and what all. Now, in a lot of cases, you don't want to necessarily focus a lot of your work here. Instead, what you want to do is lean on UIKit as much as you can. Particularly a program like this, you probably want to focus in more on that model, on that crypto behavior, and less on how things look. You probably want your application to look standard so people are familiar by just looking at it about how it might work. So again, lean on UIKit as much as you can for common view-related behaviors. And in your controller, well, your controller does, again, several different jobs, things like startup and shutdown. If it's an iPhone application, managing the navigation from one screen to the next. And as we've already talked about, mediating between models and views. And so your job here is to match the right controllers to the right job. And I'll talk about that some more later. OK, so kind of trying to think about your application. Use model view controller to think about your application, divide out the pieces so that you can just manage the big idea that you have. OK, so use MVC to divide your work to implement that big idea. OK, number 3, don't fight the framework. So color inside the lines. I was always bad at coloring inside the lines as a kid, even when I wanted to. But the idea is, to make the framework work for you. So much time and effort has gone into making these frameworks hopefully easy to use and feature-rich. So really try to make that framework work for you. Leverage it. And so let's kind of start with the don'ts first, OK? Don't fight the framework. Don't misuse framework classes. Now, one of the most common patterns that you'll see in iPhone development is the use of UI view controllers to manage a screen. Well, that UI view controller manages a view. So don't take that view out. Stick it someplace else in your application and just sort of forget about the UI view controller. That's not the way that it's intended to be used. Keep these, let the UI view controller help you manage the life cycle of that view. Right? Don't decouple these and just use one and forget the other. Right? Don't misuse the framework classes. Try to learn how they can help you, and then let them. Right? Don't re-implement framework classes. If you need a split view, use UI split view controller. If you need a scroll view, use UI scroll view. Some of these classes can be really, really tricky to implement. And you don't want to be spending your time doing that. You should really be spending your time making your application differentiated from everybody else's out there. Make it wonderful. Don't spend time doing work that we've already done. And this can sometimes be difficult when you go and you download an application and you see a feature that you like and you're not necessarily sure how it was implemented. If you find yourself spending a whole lot of time implementing what seems like a core piece of user interface, a core widget, step back and ask yourself, boy, is there some way that I can lean on UIKit to get this functionality without doing the work to make it happen? So don't re-implement framework classes. And don't make trivial UI kit classes. Use delegates and notifications. Try to learn how you can couple up a piece, match up a piece of your custom code to the classes already in UI kit. Yes, there are times when you need to subclass a UI kit class to override a method, but be careful that you don't cut off the core functionality by perhaps not calling super. Okay, and just sort of taking the work onto yourself to really make the class work as it was intended. And so don't just, again, subclass to make a trivial subclass when you can avoid it. Okay, again, the idea is to make the framework work for you. So what are some positive examples of that? So going back to this code breaker example, if you've got a model and you need to deal with pieces of text, well, use NSString. Right? That's what it's there. I mean, it's a completely full-featured string class. Don't re-implement your own. Don't try to go out and make some kind of special implementation because you think you need one. You probably don't. In terms of crypto, don't invent your own crypto, right? Use the security framework. Learn what the framework, learn what the whole OS and the set of APIs give you. Again, so that you're not spending a lot of time implementing complicated functionality that already exists. In terms of the view, I mean, again, you can imagine use table views to show lists and use UI view controllers as the documentation suggests that you should. Again, don't re-implement, don't make custom buttons. Try to use what the framework gives you to do those common interface jobs. And in terms of controllers, for startup and shutdown, we kind of have this app controller design pattern, you might say. I'll talk about that a little bit more later in terms of starting up and shutting down your app. Again, for navigations and transitions, use navigation controller. And for mediating between a model and view, really try to figure out how you can hook your custom controller behavior in at the right place, calling the right delegate methods to really mediate between models and views. And again, later, I'll talk about that a little bit more. Okay, so don't fight the framework. Really lean on it. Be aware when you feel yourself starting to invest a lot of time in a place that isn't really specific about what makes your application special. So don't abuse views, number 4. Views don't own data. Views are about data display and event capture. So this is the time in the talk that if it's a little bit early, maybe you're out, late last night, your buddy's falling asleep, so kind of give him an elbow, wake him up, because if you remember one thing about the talk, it's that views don't own data. I gave us the double Family Feud strikeout here for those of you who are old enough to remember what that might mean. I'm not going to be kissing anybody there, so don't worry about that. So. But OK, so you say, OK, views don't own data. What do I mean by this? Well, what you might be thinking is that, well, views display data, don't they? So what is this point all about? Well, the point is that the views don't own the data. They're not the place the views aren't the objects that are really responsible, ultimately, for owning a piece of data in your system. And so here's the case against. Here's why not. So I think it's a slippery slope. If you put views really in charge of owning a piece of data, then you might be tempted to put a little bit of data change methods into that view, and now your view is also sort of acting like a controller for that view. Maybe it's doing a little data validation, and it's a slippery slope. I mean, you'll be wind up like a drunk on the street, and so like, oh, poor guy, what happened to him? Well, he put data in his view, and it was all downhill from there, right? Okay. So, but the other thing that it does, one of the things is it locks you into a view implementation. Sometimes you might realize that the best way to take your iPhone app, your iPhone and iPod Touch app, and move it to the iPad is to make a different view that does a similar job. Well, what if you've got the data owned in this view? And the iPad version, do you make a copy of that data? How do you keep those copies in sync? It can really, really lock you in and force you to make some difficult decisions that you don't want to make. So keep that ownership of data out of the view. Because again, it gives you this tight coupling between data and display, which you want to avoid. And again, you want to have models and controllers really, really acting appropriately in their roles in your application. So where do they fit in? Well, they don't fit in anywhere if your views are in charge of owning the data. Another great thing that you can do, just kind of giving some positive advice, if your views don't own the data, it becomes easier to implement inspectors, which of course is now becoming common and really possible on the iPad. You'll see here that I've got a piece of text selected, and up there's a toolbar which is telling me the style of the text, and then there's also a popover view, an inspector showing me that same piece of information, the same piece of information, 3 different places in the application. This piece of information, this style information, is owned in a model object, and these views are just getting a little piece of it to customize their display appropriately. And again, you can vary the data display much, much more easily if you're just dealing with a common reference to that data that lives elsewhere. You can also vary behavior when the state of a view changes. Okay, this really talks about this idea of event capture. When the state of your application changes, your view captures the event in the same way, but then it might be passing off the processing of those captured events to, say, like a gesture recognizer, to have different behavior when the state of the view changes, in this case from a read-only to an editing mode for a particular view. The event processing of the view doesn't change, but it's just the way that the hooked-up gesture recognizer changes when the state of the application changes. So you can much more easily vary behavior by just changing an object, and the view is none the wiser. And it promotes reusability. I mean, it would be sort of silly to have each one of those text fields be some trivial subclass. I've got a first name text view, a last name text view. That's just not the way really to do it. So it helps to promote reusability. If you don't have this data hooked up in your view, when it comes time to maybe add another field because your marketing department or your management says you need one, you don't need to then sort of bloating up this view with all of these different pieces of data that could possibly be represented in the view. Again, so keeping the data out of your view helps to promote reusability. Okay, so don't abuse views. It's really about data display and event capture, not data ownership. So number 5. Plan for iPhone and iPad. So this is about dividing your code out into modules. And it's really taking the kind of this MVC organization, the MVC architecture, and kind of kicking it up to a higher level. I'll show you what I mean. So let's consider mail on iPhone. Of course, this application is shipped in 1.0. Nice, full-featured mail application is really, really, great. Sort of full-featured mail application you carry around with you all the time in your pocket, right? But what we realized pretty soon after we started developing the system was that there would be other applications which we also wanted to be able to send mail. Notes and photos are an example. So each of them have a little button there which allows you to send the note or send the photo by email. So how do we do this? Well, we factored out the common pieces. And here's how we did it. We divided things up into 3 basic layers. Down at the bottom, we have a message framework, which is all about things beneath the level of the user interface, beneath the UI. Things about networking and protocols and basic mail objects like messages and subjects and to and from, things like that. Okay? So all the non-UI elements down at the bottom level. At the middle level, we have UI elements. Things like compose views and lists of messages and controllers for mediating between the views and the model objects. And then all the way up at the top, we've got the full-featured mail application itself. Now, so I think you know where this is going. We could just then extend out those 2 bottom layers and implement the notes and the photo application up at the top. Right? Just having the custom parts at that top level, which are specific to those applications, sharing as much as we could at the bottom 2 levels. Along comes the iPad. So what to do? Well, decision was made to make great new versions of these existing applications. They're really not re-implementations or sort of a resizing of the versions that we have on the iPhone. We really rethought how these applications should work and how they might work best given the iPad and the iPad hardware and the bigger screen. And so we also realized that there were parts that we could really reuse. There were elements that we could pull out and reuse. This is a prime example of real-world code reuse. Whereas you look at that Compose view, you can really see that it is the same, only a little bit larger and shown in a popover instead of taking over the full screen. OK, so now taking this iPhone architecture, moving it to the iPad, well, what we did was this. Right, I'll kind of do that again. So we have the same, look at those two bottom layers. The bottom level, the message framework stays absolutely the same. It's not involved in anything that would need to change for the iPad. Mail protocols don't change. Right? We still need mail messages and message bodies and things like that. Stepping up to the second level, you'll see that, yeah, there needed to be some iPad additions. We had a couple of new user interface elements, a couple of different kinds of interactions. So yeah, we did need to make some additions there for the iPad. But most of it stayed the same. Again, like the Compose view is a great example of that. That didn't change. That class didn't need to change. It needed to be resized, but it didn't need to change. And then, of course, at the top, we re-implemented full new versions of these applications for the iPad. And so if you're thinking about doing this, if you've got an iPhone application now and you're trying to ask yourself, well, how can I move this to the iPad? Or you're planning a new application and you want to target both of these form factors, the iPhone and iPod Touch and the iPad, this is a pretty good way to start thinking about how you might structure your code. Again, this is kind of real-world advice. This is how we did it. And it took some back and forth to really come up with this architecture. And it really wound up working for us. So, but now you're asking yourself, real world, I want to make a framework. Well, there are no third-party frameworks. You can't make your own frameworks, right? Well, but there are still ways to sort of implement the same model, the same concept, but you would just simply have to come up with an implementation strategy that works. Static libraries and some very simple code sharing. By code sharing, I don't really mean a copy. I mean it's just really sort of an Xcode reference to the same code file in two different targets. OK? So if that's total gibberish to you, I'll even just say right now that I'm going to be down in the lab session after this session ends, and we can talk about how you might actually do this if you're interested. OK? All right. So planning for iPhone and iPad, dividing your code up, and coming up with this higher level design that will help you keep things parceled out in a good way. So number 6, strive for loose coupling. And again, this is all about keeping your code flexible and minimizing mutual dependencies. I mean, in some way, kind of standing up here now thinking about it, I mean, really, if I had to choose out what would be the second most important thing, this really might be it. I'm constantly worried about keeping the code flexible and easy to change. If one thing I think about more than anything else while I'm writing code is how can I keep it flexible so that it remains easy to change? OK, so now, what is this loose coupling all about? OK, so if you look at this architecture, it's sort of a little reimagining of the architecture diagram from before. And of course, this is in concept. Now, if we were to take like a real application and sketch out what all the pieces might look like, it doesn't wind up looking somewhat more like this, right? It's pretty complicated, right? Now, just think about if you wanted to pick out a box, pick out which box looks, like the nicest one to you, and think about changing that box. Every arrow that's going into or out of that box might need to be looked at if you're going to change that object to perhaps add a feature or fix a bug. There's lots of implications. The more arrows coming in and out of a box, the more difficult that box, the object represented by that box, is going to be to change. Okay, so here's some strategies for sort of taming all of those arrows. So striving for loose coupling. First of all, don't skip layers. Right? Use controllers to coordinate messages from models to views. Right? That's one way to tame things, one way to keep things more manageable. Again, using features like delegation, notifications, and so forth. Don't message directly from the top level to the bottom level. Don't mix MVC roles in one object. Again, this is primarily about views don't own data. That's where you might be most sorely tempted to do it. Avoid gathering too much work in one place. I mean, in some ways, if you think about it, if the work is inside of all one box, you wouldn't have any arrows. But that wouldn't be really a good idea either, because then changing that one object becomes all that much more complicated. That's almost sort of like hidden complexity that you would need to worry about. That doesn't show up on such a diagram. And finally, don't declare model data in your view classes. I think we've been over that, right? Okay. So some strategies for taming this. So here's an idea I like to think about a lot. I mean, if we focus in just on sort of a piece of your model that may need to communicate with another piece of your model, I like to avoid this bidirectional messaging. A lot of times, I try to think about a model object as being the one sort of in charge of talking to another model object. So this model object might push data over. It might call a set method. This object might call a set method on this one. And if data needs to get from this object over to this object, I'll have this one call a get accessor and pull it over. Again, so now, if I want to change this object and put another one in, I sort of know where all the touch points are. I know that this object is going to need to be the one to change, right? If I want to then maybe change a different object, I know that probably this one doesn't need to change because it's just having methods called on it. I don't have to worry about it if this one goes away. Does that make sense? I hope so. So avoid bidirectional messaging. Something else you may need to do is support multiple updates. Like if you think back to that inspector example, right? A single change to a piece of model data might need to be reflected in several places in the user interface. And key value observing, KVO, is a great way to do that. I could talk for a whole hour on KVO, but of course there's not time for that. But basically what this does is it sort of breaks these connections and makes a little transmitter and receiver. So again, now this direct connection is broken, and now you have a much looser coupling, right? Where removing one won't necessarily mean that you need to worry about that connection being fully broken for everybody. Next, look at view and controller. Lean on delegates and target action, as I've already talked about, right? A good example of this is that if you have a view that's a control, you'll get a did change method, or perhaps a UI control event value changed notification. And really what that will help you to do, I mean, this is going to be kind of a small change to this slide, but that blue arrow from the view to the controller really sort of goes away because it really then becomes more sort of system managed. It's not a piece, not a kind of communication now that you really need to worry about kind of in a first-class way. Again, sort of lessening the burden that you have in trying to keep this entire message graph managed and sort of in your head. Okay, and the last one in this little section is sort of limiting the number of connections to and from controllers. Again, I'm urging you to use controllers to keep things all managed, but you really kind of want to try also at the same time to limit the number of connections to a specific controller. And the big challenge here is to decompose controller work into the right number of controllers and the right types of controllers. And I'll talk to you about that a little bit later. So now, if you employ some of these strategies that I just talked about, you could take a graph with all of these arrows flying around here and make it something like this, which is more manageable, easier to change, more flexible, more loosely coupled. So strive for loose coupling in your program. Lean on delegates, KVO, technologies like KVO. Avoid this bidirectional messaging and try to limit the number of mutual dependencies between objects. And so that's number 6. Number 7, choose the right data model. And so the iPhone OS, iOS, gives you many, many options. And so your job is to really find the right fit, find the right way to represent your data in your programs. And so I'll just give you a minute to read that over. That's a lot of text for a slide, isn't it? Okay, I mean, that's kind of important, right? I mean, if you're certainly if you're into the deep data, but I mean, is there really 6th normal form, really? You know, is that something that you're all going to be worried about? I mean, you know, again, if you're, some part of the real world, is interested in modeling data and all of the theory behind it, but really, mostly, I think, what you're going to be worried about is taking your collection of objects, not really worrying about 6th normal form quite so much, worrying instead about how you've got this graph of objects at runtime, how are you going to get them saved out, and then how are you going to get them back into your program later if your user launches your program again or the device restarts, what have you. So this is what you're really worried about, I think, probably in a kind of the real world sort of way. So let's talk about the different data model concerns, the different things that you may need to think about where you're trying to balance these trade-offs between the different kinds of, the different choices that you have for modeling your data. Well, there are lots of them. Things like maybe are there modeling tools available? Am I going to be using SQL? Do I need transactions for complicated model transformations? What about versioning? Maybe you already know you're trying to maybe get an application out there, a quick 1.0 version, but you already know what's going to be in the 2.0 version. So you think about how to transform that data from one version to the next. Perhaps you're bringing a program over from a different platform, so perhaps you might have a large collection of legacy data already. Then there's speed and I/O and scaling and all kinds of concerns. So I'm going to try to help you, give you some tips for sifting through the options that the APIs and the OS gives you to find the best choice for you. So here are 6 different options: property lists, archives, custom files using server or cloud, SQLite, and core data. These are all, depending on your situation, any one of these or some combination might be the right choice. But I'll tell you what is not the right choice most times is using defaults or preferences. It's almost always the wrong tool for the job. Well, when is it the right tool? Well, if you can think about it, say, look at the settings panel test. If you've got a piece of data in your program that you think the best place to expose that piece of data is in settings, if you have an advanced on-off, right? If you have some feature that might be on or off, then probably user defaults and preferences is the right place for it. If you can't put that piece of data in your settings panel, then user defaults and preferences is almost certainly the wrong choice. So what are some of the right choices, right? Property lists. Property lists might be the right choice. One of their great virtues is that they're really, really simple to use, particularly if you've got, if your data is expressed in strings, numbers, arrays, dictionaries, right? The small number of core classes and data types that can be written out directly to a property list. If this is what you have, then property list might be a great choice for you. I mean, just thinking like if you had a Twitter client, for instance, sort of username, server, perhaps the people that you're following. Yeah, all of that data can be expressed pretty directly using strings, numbers, arrays, dictionaries, so forth. And again, they're very, very simple to use. Archives are also very, very simple to use. Let's say you have a custom object, and it's a collection. It's a composition of several different data types. Maybe some of them are custom, some of them aren't. Perhaps it's your object is the head of a more complicated object graph, and you just want to get that object written out to disk. Well, archives is a great way to do it. You implement these two methods, and you can read that object out and read it back in. One of the great advantages of using archives is that it supports versioning. So if you already know that you need to add a feature later, you need to add a data element later, archives can help you support that and have your data be sort of both forward and backwards compatible. And it also supports transient data. So if you have data in a particular object that doesn't need to be saved out, you also have control over that. Custom files. Of course, writing applications for iOS, you get a little slice of disk space where you can write your application data. So you can just open up that file, and perhaps if you already have some legacy code or data, again, if you're bringing an application over from another platform, you might have already done most or all of this work. This is really probably, custom files are really almost best when that's true, when you're just going to be tapping into work that you've already done. And so your job in bringing that code over to the iOS is probably going to be building an NS object-based graph out of those objects. Which perhaps it might be easier if it's a Mac application that you're bringing over. But if not, again, that's going to be your main challenge there, building up that NS object-based graph. So you could also use the server or the cloud. I think a really good example of this is if you're implemented a game and you've got a high score list that you want to save. A great example of using server or cloud. We do give you some help to implement this with NSURL classes, other lower-level networking classes. Of course, the server is up to you. There's not going to be much we can do. Even if you come to the lab later, you can plead with me, but I don't know how much we're going to be able to help when it comes time to implement the other side of this data model strategy. OK, so coming back onto the platform fully, right? SQLite is a really, really great library that we've got available for you. And it's really great if you're familiar with SQL. You can just go in there and start using the features available in this engine. Your challenge almost certainly is going to be coming up with a strategy for doing an object relational mapping. Now, I have to admit, yes, my name is Ken Kushenda, and I have a problem. I've implemented my own object relational mapping strategies. I've written languages to do it, and I've used. Right? I mean, I'm sorry. I mean, it's like the first step in the 12-step program. I don't know how many of you out there have done that too. And this can be tricky, and you can wind up spending a lot of time doing this. It can wind up working great. You can come up with custom caching strategies, custom object fault strategies. You can do all sorts of really, really neat things if you invest the time and effort to write this mapping layer. Moving on to core data. Core data is great because it gives you this wealth of features. And you can use SQLite as the backend data store for core data. And it really does solve this problem of making an object relational mapping strategy. The work is already done for you. Now, the thing about using core data is it's going to take a little bit of investment to learn how to use it and to find out about all the great features that there are. But even so, I strongly consider that you invest this time. Particularly, perhaps, if you're already familiar with the platform, and perhaps you're looking for a way to maybe take your next application to the next level, or you already know that your next application is going to be using a lot of data, I'd really, really strongly urge you to consider core data. So why? What are some of these features? There's modeling tools and very, very simple saving and restoring. You can query to get portions of your object graph returned to you. There's support for undo, which is really, really terrific. The support, again, for partial object graphs, reading in a portion of an object. Perhaps you had a blob object that refers to a large image. You want to show a list of images. Well, you don't need to read in all of the large data for the image. You can just read in the image metadata and only fault in the large image when it comes time to display it. So there's many, many wonderful features available in core data if you learn how to use them. So again, I hope that gave you some idea about the choices available. And again, if you have more questions based on this, I'll be in the lab afterward to answer any questions you may have about choosing the right data model and all of the options. Okay, so number 8, decompose controller work. And this is all about coming up with the right number of controllers for your system and learning something about the special iPhone OS, or iOS, again, old habits die hard, iOS controllers. So again, going back to this graphic, but now look at what's happening. So now this is really sort of ties into that typical iPhone type navigation from one screen to the next and then back again. Now, a lot of times, I mean, the easiest way to implement that is having one UI view controller per screen. And you have this kind of like this little sandwich, right, with a view on the top that's being managed by a UI view controller, and then the model data to support the data that's being shown in that view. And that you have one of those per screen. Now, if you think about taking that over to the iPad, you might be tempted to make just one controller, because now all those views can fit on the screen at the same time. And I think you know where I'm going with this. Don't do that. Don't avoid making an everything controller, right? You know, super, you know, it's like when you start thinking of the name, what am I going to call this? A super king daddy everything controller. No, right? That's a bad idea. That's a sign, right? When you can't think of a name for the thing and it starts getting into this manager, right? Super, manager. That's a sign that you're coupling things too tightly, gathering too much functionality into one place. So let's look at a concrete example. It's a real world implication of what that might be to kind of start gathering all of this work into a single controller. So let's see, we've got these two views and they're both pointing to the same controller. So now I'm going to change the views to actually specific view types. One of them is a scroll view and one of them is a table view. Now, table view is a scroll view. Table view is a subclass of scroll view. So now, if you had a scroll view did scroll method implemented in this one controller, you would probably need to write a line of code like this. Okay, well, all right, so if the scroll view is the table view, then I need to do the table stuff. And if it's the scroll view, then I need to do the scroll view stuff. Basically, I mean, I almost think that we should have a certain, a special feature of the OS, maybe a new Xcode feature. There's all these wonderful new features in Xcode. Maybe I'll write a bug for the next version. It's like when you type is kind of class, you'd be like a little shock coming back from the keyboard, right? This kind of class is almost never the right choice, right? It should probably autocomplete in red or something like that. I don't know. So when you do this, don't have class checks in your delegate methods. Another variation of this is that if you have two table views, you might actually be checking the identity of the view that was passed in. Well, if it's the foo view, do the table view do this. If it's the bar table view, do that. Again, that's perhaps too tight of a coupling. You might want to make two different controllers, one per table view. And absolutely avoid class checks in your delegate methods. Obviously, if you were to add another table view, this would probably fail, and you'd need another layer of if statements inside of that first block. Again, that's almost never the right way to structure your code. Keep your work parceled out, again, like this, even on iPad, even if there's enough room on the screen to fit all of your views. But now controllers play other roles in the system. I mean, kind of sort of going back to this, we've been talking a whole lot about how the controller sits between a view and a model and the relationships there. But again, these controllers, they also play different roles. So let's take a look here. This is my coolest slide, so watch this one. Isn't that cool? I'm going to do that again because I like it. So here's how you got the application controller. So now focusing in it, but seriously, what's going on here is if you create a new project in Xcode and if you use one of the custom templates, one of the default templates for an iPhone or iPad project, you're going to get, as part of the template, one of these objects. The name of this project is Bug Spray, so I get a Bug Spray app delegate class given to me by the template. And so this is the application controller. And so what is the job of this object? Well, it's the delegate of the UI application, because most likely you don't need a subclass of UI application. You can tie into the delegate methods that the UI application will call on its delegate to do important work, like starting up and shutting down your application. You might also think about it as the app controller is the root object in your entire object graph. If you were to follow sort of the parent link starting from any object in your system and follow who's the parent, who's the parent, who's the parent, who's the parent, most likely you're going to get back to the application controller as the root object in your system. And so its job is to basically get things kicked off and to turn over control to the appropriate controller. Perhaps like if you have a view on your iPhone application, it's probably going to turn over control to a navigation controller and a UI view controller. Something like that. That's a very common pattern, very typical. So again, this application controller has this special role in your system. It's not really hooked up in a one-to-one way to a single model and a single view. Although now, here's one thing that it sort of might be hooked up to through an object like NS-managed object context. If you do decide to use core data, if you follow my advice, if you already are using core data, you're familiar with this object, NS-managed object context, and it's responsible for saving objects out to storage, to write fetches to retrieve objects, and create and delete objects, and so forth. And so again, it's a controller that really just manages a model. It doesn't have a connection to a view. And I have to make a little digression here. I noticed there's a typo in the slide. And so the joke is about this is a model for a nuclear power plant. And I misspelled electricity. I hope that doesn't cause a meltdown or something like that. I hope not. Probably want to keep me as far away from nuclear power as possible. OK, so number 8, decomposing controller work. Again, this is about coming up with the right number of controllers. Don't gather too much work into too few controllers. And to learn about these special iPhone OS controllers that help you tap into specialized functionality. OK, number 9, take charge of your object graph. This one's real simple. It's about ownership and life cycle of your objects. And so what I do when I write applications is I come up with a set of rules that seem appropriate for the app that I'm writing. So I'll give you an example of what a rule might be. Well, if an object creates another, right, so this object creates this object, well, then it's this object's responsibility to release it. Very simple rule. Another rule is children don't outlive their parents. Sort of odd if you were to match that up to the real world, but inside programs it makes perfect sense, right? So this object is creates this one. This object isn't going to go away while this one is still around, right? This object is the parent. This one's the child, right? This one is going to have to go away at the same time, right? Factory objects transfer ownership. Sometimes you might have an object that is responsible for building or creating objects, perhaps as a result of maybe some networking that's gone on or whatever. But it's probably a good idea to transfer the ownership of those objects to a different one, which is sort of, in some ways, it's an exception to the first rule that I just said, right? Or actually the first 2 rules. But again, that's another rule that I might make. But for those Perl programmers out there, how many Perl programs out there? So this should just give you a little warm feeling in your heart, right? Tim Toady, right? There's more than one way to do it. My set of rules from my application may not be the same that you would use in your application. So again, it's sort of part of your job is to understand what makes sense for the app that you're writing. And so here's kind of a closer look at one of those sample rules. Again, this idea that the model might create a controller, and then the model owns that controller. And so then if the model comes time for the model to go away, well, then they both need to go away at the same time, right? That controller is not going to be around, perhaps with dangling pointers back to the model, right? if the model is to go away, right? Everything goes away. So now expanding out that rule a little bit further, right? So a model creates a controller. The controller might make the view. The view might have some subviews. Another rule that I might have is that models never own views directly except through controllers, and that views never own model or controllers. It's always that direction which is going from the model to the view. Right? That sort of ownership direction goes from one side to the other and never back. And again, that might make sense for my application. So now here's a kind of an interesting question, sort of a little bit of little details, right? Delegates are unretained. I mean, if you go, and particularly if you're new to the platform and you discover this and you see this, you might say, well, isn't this a problem? I mean, maybe I'm going to have crashes in my system when these unretained pointers get used after the objects go away. Well, here's the strategy for dealing with that. Here's why that's not a problem. Because the owner is in charge. The owner object is in charge. So now if we go back to this object and we say that the controller is the delegate for that view, right? The controller says, I'm your delegate. So now the view, its delegate points back to the controller. It's unretained. What did you just do? Well, you just avoided making a reference cycle, right? And this is not a problem because that view is not going to live longer than the controller. The controller is going to be around for the lifetime of that view, so there's never going to be an opportunity for the view to use that delegate pointer after it's gone stale, right? So it's not a problem. If you come up with these set of rules and think through their implications. So what if you have nibs? Again, the advice here is don't fight the framework. So some rules might be UI view controllers own their views. Split views own their master and detail view controllers. Views own their subviews. And UI text views do not own their text, right? I know that UI text view has a text property on it, but that's not where the text lives. Make sure that that text lives in some model object somewhere and that the text view, when it's holding on to that text, is just displaying it. So a set of rules for taking charge of your object graph. Again, you might need to think about sort of custom ways, custom rules that make the most sense for how your application works. Number 10, coordinate state changes. So this is all about updating the model after user actions and updating views after models change. Again, so kind of going back to this diagram that I referred to before. Oops. So going back to this diagram and focusing in on those arrows, how those updates and changes. Wait a minute. There we go. Oh, it's just jumping straight to the next one. OK, well, focusing in on those arrows. Well, of course, now the thing that you don't want to do is have those arrows go directly between the model and the view. That's the wrong way. Do not cut out the controller. So why not? Well, because your controller might actually do some important work there. A change might come into a user might interact with a view and create a change that would go into your controller. The controller might have some code, custom code to reject or delay or validate a particular change. Here's an example. If you look at the stocks application, that text view, I just typed Apple in there. The text view has no knowledge about what's going to happen next, that there's going to be some network access, that a table is going to be populated with a set of multiple choices, and that the user is going to choose one of them. That's going to be the responsibility of the controller to then turn around and take that change and commit it back to the model, as shown here, right? It's the controller's job to take that change and then go and tell the model about it, that the user has actually made a choice. So that's handling changes the right way. So now going the other way, let's say that, or let's go a different way. This is all about now handling multiple changes. An individual data element change and now maybe more than one aspect of the user interface needs to be updated. Again, KVO is a great way to actually make this work. Again, KVC, key value coding, and key value observing. If you have more questions about this, we'll find people who can give you some answers and some pointers. Basically, this is all about using strings rather than direct method calls to go and change your model. And you can imagine how those strings can be varied at runtime programmatically, right? That's sort of the basis of this technology. But now, kind of showing a real example. Going back to this, this complex view, right? So I've got this body 2 everywhere. Let's go and say that I change this to heading 2. And now those other 2 places after that change need to be updated appropriately. Again, so this might start in the inspector, flow into one controller. That controller is going to tell the model. It's going to then percolate these changes around. And that controller at the top is actually going to know, once the model told it that it's going to change, it's like, no, I'm the one who originated the change, so I'm not going to actually now start this infinite loop of changes going all around, which can be a problem. I mean, look, I've had bugs like that in my programs too. So this is a way to sort of master that and prevent this unintended consequences from unintended set of consequences from happening. So MVC is the way to go to manage that. So coordinate state changes, updating things as changes occur. And so there we go. There are the 10 best tips ever. And so going on them over again, learn MVC, use it to divide your work, don't fight the framework, don't abuse views, I'll know, right? And plan for iPhone and iPad, loose coupling, choosing the right data model, controllers and object graphs and state changes. And it's all about keeping your code flexible and easy to change because we want you to make great apps. So here, there's a whole set of related sessions. Fortunately, only 2 of them would require you to time travel at this point. So, which is nice. A couple nice sessions on core data and understanding foundation later today. And this session will actually be repeated. If you liked it or you want to tell your friends about it, I'm going to be doing the same show again. My devil twin will be on hand to give the repeat performance tomorrow at 2 p.m. in this room. And so thank you all for coming.